Hello everyone, and welcome to this tutorial about Jupyter. This is part 3 and it's about Python basics. This tutorial is an introduction to Python 3. This should give you a set of Pythonic skills that you will need to proceed with this tutorial series about Jupyter. If you don't have Jupyter installed in your system, you can find it using, you can start a Python session basically, a Jupyter session using tryjupyter.org. It's a really nice service and you can use it to follow with me on this tutorial. The idea of cells in interactive computing is basically you will have a code as a cell input and you execute that and you get a cell output. So in here I have 1 plus 2 in a cell. To execute a cell you can use this button, run a cell, but mostly if you're using a keyboard to write code, you want to execute code using the keyboard shortcut, which is shift and enter. So if I do that, I get 1 plus 2 equals 3. If you have two operations in one cell, like 1 plus 1 and 1 plus 2, it will only return the value of the last operation. So it doesn't matter how many operations you have in a cell, it will only return the last one. You can show multiple values using the print function. So in here, if I had a situation like this and I wanted to return both of them, I could have printed both of them or just printed at least the first one. So to print something, use the print function. If you're familiar with Python 2, you did not have to add parentheses around this because it was a statement, not a function. In Python 3, this will not work and it will be an error basically. So you have to add parentheses to your code whenever you're printing. So print 1 plus 2, it doesn't return an output, it just prints in the output area. But there is no output of this cell because I did not return anything. I just printed something out. So this is the system output basically, not a return of that cell, if that makes any sense. Anyway, variables in Python 3, they're a little different than Python 2 in a good way. You still have the boolean, which is true or false. You still have integer, but integers now represent integers and long values. So there is no special type for longs and special type for integers. They're both integers now. Float to represent decimal values, and complex numbers to represent imaginary numbers. And there is no more L at the end of long values now. In here I'm defining few values. A is an integer, B is a float, C is not long, it's also an integer now. D is a complex number. E is a float again because it's I'm dividing 1 by 3. And finally F is a boolean. So if I execute that, I created all these variables. I can say a plus b, and it will add these two numbers. I can multiply a by c, and it does not return that little l at the end, like Python 2. Now it just returns the value, which is much better. You can do something more complex by adding few numbers and multiplying. And even if you have complex numbers and integers, it will just calculate the values fine in here. If you add an integer to a boolean, so 4 plus true, which is a plus f, equals 5, because it's assuming that value true equals 1 and value false equals 0. So it's 4 plus 1 equals 5 basically. You can use the type function to know the type of any variable you have in your system. So the type of the value 1.5 is a float, and the value of 1 is integer, and the value of true is boolean. Other types, string, list, tuple, and dictionary. With the strings, you can define a string with double quotes or single quotes. So feel okay to use either one that feels more natural to you, or from any programming background you come from. Both of them will work just fine. And you can mix and match. You can say, you can define some of them with double quotes and some of them with single quote in the same quote. It's not really optimal, but sometimes you have to do such tricks to do something in your code. So I'm printing this variable and it returns a string. The second thing we have is lists. So I'm defining a list with values of 1, 2, 3, 4, 5 and returning that. It returns my list. If I add something to my list, I'm adding another list here. I'm not adding a single value. It's not 6 plus my list. It's 6. It's my list plus a list that includes only a single value of 6. That returns my list basically with appended value at the end, 6. That did not change my list. If I check my list again, it's only from 1 to 5. That did not change my list. If I want to change my list, I will have to store the output in the list. The easiest way to do that is my list plus equals another list that includes 6, 7, 8. If I execute that, it will return my list, my modified list now with values from 1 to 8. Plus equals is exactly like saying my list equals my list plus something else. So plus equals just makes your code more readable and shorter. Append is a function that you have in your list that can add single value. In here, I'm not adding a list, basically. I'm adding a single value to my list, and it will modify my list, and it will add a value of 9. Tuples are like lists. I will not go into the technical differences between them, but you should always use lists if you have, unless you have to use tuples, basically. You can append tuples together like lists, but there isn't much to do with the tuples after you define them, basically. Dictionaries, you can have a key value pair type variable. So in here I have inside my dictionary 2 keys, name and credit, and their values, Roshan and 100. And if I execute that, it will return a dictionary including 2 keys and 2 values. You can return a single value by using the key for this value. So if I want to return the name inside this dictionary, I can use name. You can define other keys and values inside your dictionary just by defining them. So I can add the key level, and I can add the value 4 to my dictionary, and you can see that in here. You can get all the values inside your dictionary using the values function, and you can return all the keys using the keys function. Dealing with the lists for selecting and slicing, the first thing is the lim function. It's very useful. It will measure the length of a list or a list-like object, and it returns in here the length of my list. I can select a single value using its index, so it's a 0-based index. So if I use 0, I will get the first value in my list. I can select multiple values, and here I'm returning a single value. In here I'm returning, if you're using this selecting format, it's called the slice, where you have a start, end, and a step. So if I select from 1 to 2, it will return only a single value, but it's a single value inside the list. It's not just a single value like this. It doesn't select the last, the end index. It stops just before the end index. So if you start from 1 and end at 2, it will only return value number 1 in your list. If you leave the start empty, it will assume the start is the beginning. So it will return everything until 3. It will stop just before index 3. If I start from 3, and leave the end empty, it will assume that I want the list until the last value. You can use negative indexing. In here I'm using -1, which will assume which will give me the last value of my list basically. If I use -2, it will give me the second last value of my list. You can use negative indexing also in slicing. So if you start from -2, it will start from the second last value. So it will start from 8. If you stop at a negative index, it will stop at the second, just before the second value in your list. So it will list everything and will stop just before the second value from the end. It starts at 1. It doesn't start at 2. So in here, it doesn't start at 0. So because there is no -0 basically. So the last value is -1, not -0. You can mix between positive and negative selectors basically. So I can start from the third value or value with index 3 and stop just before the last value, which will return the list like this. It will not return 9 and it will not show the first 3 values in this list, which are 0, 1, and 2. The third location in your selector is the step. So if I put a step of 2, it will give me every other value. I can start from the third one and get every other value. And I can use negative step. Negative step will look at what will invert basically your list. You can use -2 and it will invert your index and use a step of 2. So it will show every other value in your index, in your list basically. Working with strings, you can work with strings just like lists. So you can use start, end, and step. So if I get my name of index -1, that will return the last letter in my name. I can get my name until index 2, so it will return only the first 2 letters in this variable. Working with the Unicode is a little different in Python 3. You don't have to add a U before your Unicode variables. That's not the case in Python 3. You can all strings are equal now. You can just use a string variable to store any Unicode value inside it. So in here I have a dictionary with the error you cannot divide by 0 in few languages, and I'm printing the Hindi one basically. The interesting thing, when you check the type of this value, you will get the type of this variable is string. Oh, this should not be here actually. This is the almost equal to. Anyway, so it will return a string, not Unicode. So all Unicode variables are strings in Python 3. String formatting, you can have a template string basically, like value equals, then a placeholder, and you can insert anything inside this placeholder using the percentage. So to see this at work, I have first name and last name, and I want to format them in a way that shows the last name first, comma, space, then only the first letter of the first name, then dot. And if I execute that, it will give me the last name, comma, space, the first letter of the first name, then dot. You can use another placeholder that formats floats to a number of decimal values using dot, then the number of decimal values, then F. So if I want to print pi only to the third decimal value, I can use 3. I can change that to 2 and print it, and it will print a pi like this. In here I have another string that shows a student's grades. In here I'm defining 3 integers or 3 numbers basically. representing their grades for homework, midterm, and final. I'm calculating their total. And to show new lines here, I'm using \n, which is the new line escape character in Python. Using the format function, you can use the format function to pass to specify basically the name of placeholders. So in here you see that we don't have names for the placeholders. So the first one will go into the first one, the second one will go into the second one, and that's the way it works. In here I can specify a name of a placeholder, and I can mention that name as a parameter in my format function. So in here I have a URL that takes you to Wikipedia page, and I can specify the language using the format. So in here I want to show it in English, and it will print it like this. Mathematics, we can do add, subtract, we can do divide also. But dividing in Python 3, if you're familiar with Python 2, if you divide it to integers, it will assume that you want an integer division, so it should return only 2. That's not the case in Python 3. It will assume that it's a float division, even if both values are integer. If you want to enforce that, you can use the double slash operator, which is an integer division. You can multiply 2 times 5 is 10, and you can use power, so a to the power n is a asterisk asterisk n. So a to the 2 to the power 3 is 8. You can use mod, which will return basically the r, the remaining of division. So the remaining of dividing 10 by 3 is 1, because it's 10 divided by 3 is 3 with the remaining of 1, so that will return the remaining. You can add import other libraries to your notebook using the import statement. So you can import a library, and you can import it as an alias. This is really common with common libraries like NumPy and SciPy. So NumPy, it's always or most of the time imported as MP to make your coding faster. So I will be importing math, which has few functions that are interesting and useful if you're doing some math work. So in here I have 2 variables, n equals 52 and k equals 1, and I'm returning math.factorial of n divided by math.factorial of k times math of factorial of n minus k, and that returns 52. I think if any of you studied statistics, you will be familiar with this equation. It's interesting anyway. Loops, you can do a for loop. So to do that, use for, then a variable that holds the tally of your counter, and n, then you pass anything that you can iterate over. So in here I'm passing a list that has 1, 2, 3, 4, 1, 2, 3, 4, and I'm printing counter each time, so it will print 1, 2, 3, 4. You can use range. Sometimes you have a lot of values and you cannot just specify every value. So if you want to create a value from 1 to 100, you don't have to type every value from 1 to 100. You can use the range function, which returns not a list, but an iterable that's that you can use just like a list. So for counter in range of 5, that will return all the values and stop just before 5. So it will return values from 0, 1, 2, 3, 4. You can specify a start and stop and step just like lists in here. It doesn't reach the last value in your function, and this is to make this right, to make range of 1 to 10 equals 1 to 5, plus 5 to 10. So I'm not skipping one number in here. I'm using the same value, and if I execute that, it will tell me it's correct. The range of 1 to 10 equals the range of 1 to 5 plus the range of 5 to 10. To check if something is equal in Python 2 and 3, it's the same thing. It's equal. And to check if something is not equal to, in Python 2, you could use either asterisk equals or greater than, less than. In Python 3, you cannot use this anymore. You have to use the asterisk equals to have an operator of not equal to. In here, if I specify the starting point in this range, it will start from 1 and it will stop just before 5. And I can use also the step to have it start from 2 and give me every other value until 10 and stop just before 10. You can use a while loop, so you can do that with while. Then you will have a condition in here, and as long as this condition returns true, it will keep executing this loop. So in here I have a counter, and I'm incrementing this counter each time by 1 and checking if it's less than 5. So it will just return 1, 2, 3, 4. F statements, you can say if math .py equals 3.2. Then Mr. Goodwin was right. Edward Goodwin was right. If you're not familiar with this story, it's a geeky mathematics thing. I left few links in here to it if you're interested. And it will check if math equals 3.2, it will print Mr. Goodwin was right. Otherwise, it will print pi is irrational, and definitely pi is irrational. You can have an else if. The way to write that in Python is elif. And in here I have if math of square root of 2 equals 10 over 7, then the same guy was right. And if it doesn't equal to 10 over 7, square root of 2 is irrational. And definitely square root of 2 is irrational. I left few links in here. If it's a really nice story about a weird mixture of politics and mathematics about pi. It's a really interesting story where by law they almost set pi to equal 3.2. Anyway, probability equals 0.3. So I'm setting a variable named probability to 0.3, and I'm checking if probability is higher than 0.75, if it's higher than 0.5, if it's higher than 0.25, or else. So it will just visualize, it will return a text-based representation of this float number. So that's what I'm doing here. So if I made this to equal 0.8, it will be a sure thing. If I made that into a 0.1, it will tell me no way. Functions, you can define functions. So in here I'm defining a small function that calculates the circumference of a circle. So and it's basically the keyword def, then the name of my function. Then I can specify any parameters I want in here. Then make sure you use the statement return, and then return whatever value you want. And here I'm just saying math.py times r times 2, which is the formula for that. But instead of mentioning this formula over and over in my code, I can just use now this handy little function to do that. In here I'm defining the function for the binomial coefficient that I slightly mentioned before. And when I execute this cell, I'm calling this function at the end of the cell with the values of 52 and 2. If you see this area, this is called a doc string. This is a way to document your function. So if anyone else wants to use your function later, they will know what to expect from your function, basically. The way to access that, if you cannot see the source code of the function and you want to access that from Jupyter, you hit Shift, you go inside the parentheses, and then you hit Shift and Tab. And that will pop up this little tool tab box. And if you expand it, you will see the doc string area. You will see that this function returns the binomial coefficient parameters, and it shows what it returns, basically. If you like math, this is the binomial coefficient function. That's the formula for that. In here, I'm calculating how many ways to select 2 cards from a deck of 52 cards using this formula, and it returns 1326. And if you're interested in this, try to see how many ways you can select 2 cards from a deck of 52 cards. If order didn't matter, just like the previous one, but you could select the same card twice. So you would select the card and return it, then you would select another card. How many ways you could do that? This is the Wikipedia link to this, and this is the formula. And if you can tell me how many ways to select 2 cards from a deck of 52 cards, if you could choose the same card twice, leave that as a comment to this video. And if you get the value of 1326, that's just wrong. The last quiz was actually solved by Pakri. I'm sure I'm pronouncing it wrong, but thank you, Pakri, for solving the last quiz. This tutorial is available open source on GitHub, and it's viewable on MBViewer. Feel free to use any of the content in here for any purpose you need. Thank you for watching, and I hope if you like this, you will subscribe to this channel and you will watch the previous part, which was about Markdown and LaTeX, or the next part, which will be about NumPy. Thank you.